Today we will deal with the Phasor algebra or vector algebra. Algebra means algebra. We are already familiar with algebra. In algebra we will have a plus b whole square and a cube plus b cube and a square minus b square, and all will be come under algebra. But in vector algebra we will have the same operation. The same operation means operators are addition operator and subtraction, multiplication and division of vectors. This is vector algebra simply. And Phasor algebra means the same addition, subtraction, multiplication and division of phasors. Okay. Phasor is represented by vector quantity, vector, and it is represented by complex number. Complex quantity or complex number can be represented in two ways: rectangular form and polar form. What is the exact meaning of these things first? Rectangular form and polar form. We already know. We know that a constant, a definite length phasor rotating with respect to a reference point is, and it can be represented in the form of like it is having some magnitude and having some angle or at an angle theta. This is polar form. And if it is, we know that by converting polar into coordinates axis, for suppose we have our vector at this point, so we can project into x and y. It's a component method, x and y, and is represented in the form of x component plus j and y component. This is rectangular form. So representing one number in polar form and rectangular form, we will use the advantage of simplification by using these two forms. We will have many advantages. Later we will come to know. Here the operator j, the j is called j operator. J operator. Suppose we have a quantity I phasor, and this phasor can be, or this phasor can be represented like, or it is rotated as a phasor. Again I made a mistake, sorry. This is a phasor, okay, and it is rotating. Assume that it is rotating. Right? Whenever it rotates 90 degrees, let us assume it as a j I, and if it rotates 180 degrees, let us assume j square, and if it is assumed, it means j cube, that is minus j, again 0. Suppose j square means 180 degrees, right? So here we are getting the same I in opposite direction. So the same I in opposite direction is minus I. That is exactly j square I. We are representing j square I. So j square can be written as minus 1. Right? J square equal to minus 1. And j cube is again j square into j. J square is minus 1, right? Minus j. That is third one. 270 degrees. And for 90 degrees, it is j. For 180 degrees, it is minus 1 or j square. For 270 degrees, it is minus j. This is the j notation, j operator. J can be written as j equal to j square equal to minus 1, right? So that implies j equal to square root of minus 1. This is a simple assumption, just simple notation to simplify the complex numbers, to modify the complex numbers. Okay. So a number in the form of a plus jb, as I explained, like x plus jy, this is in rectangular form in a complex number. Similarly, a plus jb is also a complex number. Okay, here a phasor, mathematical form of a phasor, mathematical form of phasor. In how many ways we can represent phasor? First one, rectangular form, I already explained. Rectangular means in the form of x plus jy. Second one, trigonometrical form or polar form. Polar form is r at an angle theta. Okay, and third one is exponential form. Exponential form, e power of j theta, simply. And before that, we will have some magnitude here, say some a, okay, a into e power j theta. And fourth one, trigonometric form. Trigonometric form will be some magnitude way into cos theta plus j sin theta. This is similar to this one, x component and y component. X component, we know that x1 cos theta, x cos theta, y component y sin theta, and x and y both are same, their magnitude maximum value. Here that is a cos theta plus j a sin theta. These two are similar. Okay. Suppose if z is a complex number a plus jb, and we can write a minus jb as z star. This is complex conjugate to the complex conjugate of z. Z star is complex conjugate of z. And now we will perform some mathematical operations on complex numbers. Addition. Consider two phasor quantities, v1 equal to a1 plus jb1 and v2 equal to a2 minus jb2. So addition is v1 plus v2, that equal to a1 plus jb1 plus a2 minus jb2, that equal to a1 plus a2 plus j is common, b1 minus b2, okay, that equal to capital V. So capital V equal to a1 plus a2 plus j into b1 minus b2, and magnitude can be treated as a1 plus a2 whole square plus b1 minus b2 whole square. The concept behind this addition, multiplication, complex number, vector numbers, phasors, and all these things you can refer essential mathematics for electrical science. Okay. And similarly subtraction we can perform, and similarly multiplication and division. But for addition and multiplication, see, there is a key. For addition in rectangular form, it is very advantageous. Addition and subtraction, both, and subtraction. For multiplication and division, it must be in polar form. Of course, we can do in any form, but if it is in polar form, it is very advantageous. For addition and multiplication, if it is in rectangular form, it is very advantageous. Now we will do some problems regarding these things. This is the problem asked in 2003 public exams. Now perform the following operations and put the result in a polar form. The operations are addition, subtraction, multiplication and division, where a equal to 6 plus j8 and b equal to 3 minus j4. The first one is a plus b. This is addition, so the a and b must be in rectangular form for easy calculation, right? So we will consider a equal to, that means a plus b equal to, directly we can write 6 plus j8 plus 3 minus j4, and that equal to 6 plus 3 plus j8 minus j4. We can make j as common term, 8 minus 4, that equal to 9 plus j4. This is a plus b, and it should be expressed in polar form. For polar form, that should be in the form of r at an angle theta, where r equal to x component, that means a square plus b square, that means 9 square plus 4 square, that equal to 81 square plus 16. 81 plus 16. That is how much? That equal to 9.85 r, and theta equal to tan inverse of y component by x component, b by a, 4 by 9, that equal to 23.96 degrees. So a plus b equal to 9.85 at an angle 23.96 degrees is the answer for a plus b. Okay, similarly a minus b. A minus b is homework for you. Second one, a minus b. Now third one, a into b. For multiplication, the polar representation is advantageous, right? for polar representation is advantageous. So A equal to 6 plus J8, and it can be represented directly. I am writing 10 at an angle 53.13 degrees, and B equal to 3 minus J4. It can be directly written as 5 at an angle minus 53.13 degrees. A into B equal to 10 at an angle 53 into 13 degrees into 5 at an angle minus 53 13 degrees. For multiplication, the magnitude will be multiplied and angles will be added, plus minus 53 into 13, and these are cancelled as 0. This is 50 at an angle 0 degrees. A into B. Similarly, the fourth one is A divided by B. This is very simple. A by B equal to, for this also polar is needed, polar representation, 10 at an angle 53.13 degrees by 5 at an angle minus 53.13 degrees. Here for division, the magnitudes are divided, but angles will be subtracted. 53 minus of minus 53.13 and minus into minus plus, so that equal to 2 at an angle 106.26 degrees. This is A divided by B. Okay.